Yeah. Hello all, thank you for coming in today. I'm Gaurav Nelson, and you have already got my intro. So I work at Red Hat, and we have a big technical writing team at Red Hat. So I'm a principal technical writer, and I work with lots of junior writers and help them out as well. So that's kind of what I do. So back in November 2022, when ChatGPT was made public, so like everyone else, I really thought it's a really cool technology, and I was fascinated by it. I loved the responses it generated and how it had knowledge of different domains, and it could, yeah, answer even complex queries and like everything in between. But as I um, kind of used it after the honeymoon period, it came to me like it's not like all good things that come out of it, and oftentimes it is wrong. So um, when we now think about the progress AI has made during recent years, it has been really significant. So um, in 2023, we got newer, better models than what we had during the initial times. And we also saw lots of open source models. So when open source models came out, that was actually the time where I played more with the AI tools. And also during that time, uh, uh, with open source came smaller models, which you can install on your machines and usually do more things. So yeah, being working at an open source company, it's always good to see open source progressing in the right directions and giving everyone access to use it. Coming to 2024 now, we have multi-modal uh, language models, which could not only take text as input, but also like images, videos, and voice as well. Seeing the GPT-4o videos, this probably it was quite amazing actually that you could talk to AI and it responds back. So, um, through all these years, I've tried to make AI review my content. Uh, uh, it's like Jared mentioned that I'll show you how I use AI to review my content, but it's actually uh, not that. So I'll just talk about how I tried using AI to review my content and the journey I took, what all things I've tried, and what actually I uh, uh, learned through that exercise. So I'll share those things. Along with it, I'll also talk about various tools I use. You can try them out. Um, uh, Mostly free and open source. So no issues there. So when it comes to documentation with AI, there are various use cases that, that's, that we can talk about. So mostly uh, everyone talk about are the first and second one. So which is the first one is mostly about you give a large language model some like engineering documentation or like requirement documentations, use cases, and then it will come up or generate like new documentation or sort of first draft, which writers can then take and work on. The other um, use case, the second one, which is you have a documentation site and you just want to add some sort of AI that can answer user questions and sort of provide some interactivity with your existing documentation. And then uh, other tasks could be The one which I wanted to do was review. Um, there are many other tasks that AI can handle, but I will only focus on reviewing the content. So, being a senior writer at Red Hat, I usually do lots of reviews for texts coming from other writers. And we now use Whale, which is a tool in which you define the rules, and it basically checks your text against those rules and show if there are any errors. The way you set the rules in Whale is using regular expressions and scripts. So Whale goes through your text and show any inconsistencies based on those rules. But it's limited in terms of how you can create the rules. You can only use regular expressions, and it allows you to define rules based on like grammar, um, but it's like difficult. It's not easy or straightforward to make like natural language processing rules and things like that. So based on that, my quest began to just work with AI. Hopefully, I give text to AI and it will just rewrite my text based on following all the style guides and other rules I've set up, and I'll get like a final document. So that would not only help me, but it can help like other writers to sort of be the first check they can run through. So I started with the most basic technique, which is prompting, which is just in addition to the question you put on to the large language model, you just give some context and some additional information like how you want the response to be. And the AI will then generate the text based on that prompt. So there are many, like nowadays there are different, on internet you can find templates. There are many sites which have prompt templates, which you can just download or copy paste to use when you talk with LLM, and it will give you good results. So based on that, I first tried to create a prompt with a goal, context, and an expectation. So the reasoning behind creating this prompt was that I thought, I believe that large language models are actually trained on all the data that exists on the internet. So our style guide that we use is open source. So I thought that it would have already the knowledge. So I just said that follow the IBM style guide and do this to my text. I'll show you the output example after that. After this slide. So similar to prompting, another piece of what do you call it? Another maybe a way to do things is called agents. So with prompting, you are only talking to one LLM and getting the response. With agent, you distribute the tasks to multiple LLMs and then get the results from all of them. So for example, you can set one LLM to identify all the issues in a piece of text. And then you have like a second LLM that would take the input, like all the issues, and then rewrite the text based on that input. So there are various softwares or libraries available to like do that locally on your machine. Otherwise, there's also a really cool and free option with Amazon Party Rock. So, so based on that, so Party Rock is an app where you can create um, applications with agents. Agents are basically large language models, and you can use like multiple models together to get your responses. Party Rock is not free, but they do have pretty generous limits, so you can go ahead and try this. So in this example, um, it is using two LLMs. One is for suggestions. So on the left, you can see the prompt I've used. So the first LLM, it will just go through the user input, and it finds the issues, and then I have another piece suggestion, which will go through the user input and the issues, and then yeah, prints out the final text. So instead of one, I'm using two in hopes for getting better responses. Let's see. So here is the one with example. I think Swapnil will share the slide deck after with Meetup. So it's free. You can go to the link and test it yourself. So the problem with this is sometimes the issues it identifies are not issues. In AI terms, they like to call it hallucinations, but it's actually wrong answers. It's incorrect responses. So I thought maybe introduce one more LLM to fix that. But I tried one more. I put a validate step in between. I created a new one. So and I gave the tasks to check if issues are really issues, and then give me the suggestion. Yeah. So after doing this, I found out it's still not up to the standards. It would even with like multiple LLMs, it would it would generate false data and say things which aren't true at all. So that was a big problem with prompting and agents. It just can't get the job done what I wanted it to do. So next thing I tried was retrieval-augmented generation, often called as RAG, in which you provide the data you have to the model. So when it answers, it actually checks the data you provide before answering to your query. So the way it works is, for example, if you have a documentation site or a PDF, a collection of PDFs, you put it using tools and it converts it into a vector database. Vector database is what LLM uses to like figure out which word comes next after the other words. So, yeah, if you read more about how LLM works, it would be clear. So when it generates responses, it use that vector database and then improve upon its response before giving you the final response. So I tried that RAG techniques. I uploaded my style guide. I used both of them with similar. So both of these tools would run locally on my machine, but you'll need a GPU to run them. So like it would run on M1 Max and or Linux or Windows machines with graphic cards. So I did that, and even with the style guide and you know, even with the style guide, it did not respond to how I wanted. So in this example, I was trying to this is the example for conscious writing. I was trying to avoid the certain terms which could be offensive. So um, I tried that, but even with RAG, it did not pick up those changes from the style. So the main problem with RAG is it is good for getting information. It's good for searching information. For example, if you're creating a documentation chatbot that could go through your docs and present information like as answers, it would work in that scenario, but it wouldn't work for reviewing the content. So that was a fail again. So the next thing on my list was fine tuning. So fine tuning is basically teaching large language model to do things how we want to do it. So which involves creating data sets. Data sets are you can think of it as like a comma separated value files where you put the most simplest could be the instruction, what you want to do, and then input that goes in, and output is what response the LLM should generate. If you create like a big CSV file with thousands of such entries, it would be, and then basically you have to run the training program to train the LLM. It would really give you the answers like how you would it. So in terms of creating data sets for fine tuning, you can basically create synthetic data, which is you ask another LLM to create this question answer pairs. So you would just say that give me a list of 10 entries for following this instruction, input and output patterns, and it will generate. So it's LLM generated content, it's synthetic data, but it would work in some scenarios. The first thing I did was there's a open source model from IBM called InstructLab, so which you can it allows easy training of the model. You can run it on your local machine, and it generates. So you have to just define like a configuration file and put like a few example in there. And then it will read through that file, and it automatically generates hundreds or thousands of entries for you. And then you can use that generated data to train that model. So that was the first thing I did. I created I created a data set. I created a data set like that, which has input, output, and instruction in that. In the instruction is the instruction which is common across all, and then input is the wrong text and output is the correct text. So this one is I've created this for few of the rules from our standard, and you can see it has only 76 entries. So I use this data set to train the model. Um, so there are like lots of technicalities when it comes to fine tuning. There are different models. There are different types of data sets. Uh, you would need to train those models, and there are like different ways of training as well. So after the data set I showed you was not from the Instruct Lab, but Instruct Lab like creates it on the machine and then trains. So this example is for Instruct Lab. Um, um, I've given this a prompt and it gave me the response, and it correctly like replaced the terms I wanted to replace easily. So, so this is the response and this is the explanations and this the second example. This is to Unsloth. So Unsloth is again open source set of tools. It provides you ready-made Google Colab worksheets. So you can, so Google Colab is it's a service, free service. It provides some GPUs you can use for free. So Unsloth allows you to use Google Colab to train your large language models. So I created that 76 rows data set and used Unsloth to train a model. The model I used was P3 from Microsoft. It's because of its small size, it was like 3 billion parameter model. The smaller the model, the smaller the size. It's around 3 gigabytes. Also, training takes time and resources. So, but it gave me the perfect output I was looking for. So, like I found out like fine tuning is really good at solving the problem I wanted to solve. Yeah, but fine tuning is not a silver bullet. The most difficult part of fine tuning is creating a data set. So if we, in terms of creating data set for a style guide, it would require large amounts of data. So it's definitely not a single person's task. Like you would need a whole team of people to go through the style guide and create like entries with wrong things and right things. Obviously, you can automate parts of it, but definitely you need like large amounts of data. When I say large, the better the data set you provide, the better the output from the language model will be. So some of the data sets on Hugging Face, they have like millions of like rows of data, which is quite a big task for like humans. So it is, and then you would need GPUs for training, and depending upon the model you choose, it takes time. So, for example, with the instructional app, when I trained it on the data, it took like around 1 hour to like for generating the synthetic data. It took around 15-20 minutes, and on my machine, it took like around 1 hour to actually like train the model and give me a new model. For Unsloth, when I did the P3, it took probably around an hour or so for only those 76 rows. So, I mean, assuming if you have millions of rows or even thousands, it would take yeah, quite some time and resources to do that. And of course, like GPUs, it's very costly these days, like running and training your own model. It's costly, but it does provide the output you want. So in conclusion, like I would just say it's it's a team effort. So at Red Hat, currently we are still exploring how we can use AI in our docs processes, and we have identified things we can do with AI, and like reviewing content with AI is one of the use cases we have. So one lucky thing with being a big organization is that we have access to the GPUs and like training and engineering resources and all those things. So yeah, obviously, like if it passes through organization's approval, then we can like start working on this use case and make like a better model that can review our content. Yeah. So thank you all for listening. This is what I have to present. You can find me on LinkedIn at Gaurav Nelson, and yeah, I have a blog as well where I've put in some blog posts, which essentially talks in details about what I did, and it's like more, it has like more technical information and links and stuff. So you can find it there. Thank you so much.
That's right. We'll stop the recording, and then we can do questions if anyone has any.